Okay, modern atomic theory notes. We're going to start with the present-day model of the atom. We kind of did the evolution of the atom, what we think now is the present-day model. We showed kind of how it evolved. Now we're going to talk about it. Basically, electrons act like both particles and waves. And so we're going to write the word particles here. And waves. And light waves, like light waves, electrons can change direction through diffraction. So they kind of act like light does, the photons of light. By the way, diffraction, hopefully you can read my messy writing, is the bending of a light wave the bending of a wave as the wave passes by the edge of an object. Electron beams, like waves, can interfere with each other. So we're going to put electron beams in there. Okay? Now, the modern model of the atom takes into account both the particle and wave properties of electrons. So we're going to put particle and wave. Properties of electrons. According to this model, electrons are located in orbitals, which are regions around a nucleus that correspond to specific energy levels. And we do know that orbitals are regions where electrons are likely to be found. We can't pinpoint the exact location of an electron, but we can say it's somewhere in this little area. Orbitals are sometimes called electron clouds because they do not have sharp boundaries. Okay. So let's talk about the structure of the atom. We know that there's protons, neutrons, and electrons. And I hate writing out the words all the time, so a lot of times I use the chemical shorthand. So right now we got protons, neutrons, and electrons. So protons, we're going to put little p+. Kind of gives you an indication of their charge, which you guys should know already. Okay, so we know that protons have a charge of a positive, and they are inside the nucleus. Now, what about their weight, or their average or relative mass? It's 1 AMU. What does AMU stand for? It stands for atomic mass unit. Scientists just had to come up with some sort of unit, so that's what they called it. Okay, now your neutrons also have an atomic mass of 1 AMU, but they have no charge. And we know that they're also found inside the nucleus. Then we have electrons. Now, electrons are teensy tiny. In fact, they are almost 2,000 times smaller than a proton. So it's 1 over 1836. That's how big they are. Teensy, 2,000 times smaller than a proton. Now, they have a negative charge, and they're found outside the nucleus, which we already know, kind of orbiting around the nucleus. Okay, so now, what's the atomic number? You guys should know that answer from your definitions. It's the number of protons. Now, since atoms are neutral, they weren't neutral. Every time we touch something, we would get an electric charge or get an electric zap, get zapped. But since we don't get a zap when we touch things, atoms are neutral. And that means the number of protons is equal to the number of electrons. Okay? And now, the mass number, you should also know what that is from your definitions. It is the number of protons plus the number of neutrons. Okay? Now, to find the mass number on the periodic table, you got to round the atomic mass to the nearest whole number. Okay? So that's the easiest way to do it. Oh, yeah, it's also written on this slide. Okay, now to find the number of neutrons, we're going to take the mass number, and which is the number of protons and neutrons, and we're going to subtract the atomic number, which is the number of protons, and that should give us the number of neutrons. So let's look at carbon. Carbon has an atomic number of 6, so it's got 6 protons and 6 electrons. To find the neutrons, we're going to take the mass number, which is 12, minus the atomic number, which is 6, so we get 6 neutrons. Now, that's not always the same. So don't think that because it has 6 protons, it's always going to have 6 neutrons. Carbon, yes. Other things, no. Okay, you still have to do the subtraction. I just tried to get some easy examples. So let's look at sulfur. Sulfur has an atomic number of 16, so it's got 16 protons and 16 electrons. And when you take the 32, which is the mass number, minus the atomic number, you do get 16 neutrons. And guys, it's as easy as that. Okay, let's talk about isotopes. Now, you guys know all about isotopes. You should anyway, or at least should have heard it. Plus the definition I gave in the glossary, something like it's the same number of protons, elements of the same with the same number of protons and different numbers of neutrons. So let's put those words in there. So some atoms have different numbers of neutrons, but they still have the same number of protons because it's still the same element. Okay, so these are called isotopes. So let's look at carbon. There are 3 main isotopes of carbon. Yes, there's more than 3 isotopes of carbon, but there's 3 main isotopes. So we got carbon-12, carbon-13, and carbon-14. Now, these numbers stand for the mass number. Now, carbon, if you look it up on the periodic table, has an atomic number of 6. Well, also from the previous slide. So the number of protons will always be 6 in all of these isotopes. It's getting the number of neutrons. That's where it's going to vary. So we're going to take 12 minus 6 to get 6 neutrons for carbon-12. Carbon-13 has 7 neutrons, and carbon-14 has 8 neutrons. Now, sometimes scientists get lazy, and we like to write the isotopes a little bit different way. So sometimes you're going to see it with the 12 at the top and the 6 at the bottom. Well, the 12 is the mass number, and the 6 is the atomic number. Or you might just see it as, carbon with the 12 on it. They get even lazier and don't even bother writing the atomic number because for carbon, it's known. Okay? Now let's look at the periodic table. One of the squares in the periodic table has information in it. So it first has the chemical symbol. So we'll look at magnesium, which has a chemical symbol of Mg. And you'll find that there's a 12 at the top and a 24.312. So there's a decimal number at the bottom. Well, this decimal number is the atomic mass. Now, in order to get the mass number, I'm going to write atomic mass down. You need to round this number to the nearest whole number, which in this case is 24. And then at the top is the atomic number, okay, which is the number of protons. And that's basically the information you can get. There's a little more information than that, but for right now, that's all you have to worry about. Okay, I want you to do some practice problems tonight. I want you to tell me the number of, let's move it up a little bit. Okay, so practice. I want you to find, for all of these, I want you to find the number of electrons, the number of protons, and the number of neutrons for the following elements. Now, you're going to have to find the atomic symbol for them. So I want you to do, let's do zinc. Well, Zn is zinc. We'll do helium, hydrogen, oxygen, and try to do uranium. So those are the 5. So I want you to find the number of electrons, protons, and neutrons in them. Okay, all done. Bye.